Hello everybody, Brian here from quantlabs.net. Just wanted to hopefully give you some useful tips. When you're trying to understand algorithms, specifically in my case, say the Brownian motion, I came across online two projects from the same author. I'm looking at Brownian motion simulator. There's actually four versions of it: Matlab version, C, C++, and a Fortran version. So right now I'm going to just show the Matlab version. Just come here, I'll put the links into my blog, where to get this from, and so far so good on the Matlab version. Okay, so I've downloaded all the source code from below here, and let me just show you what we have. Right now we've got two M files, Matlab code files. Brownian motion simulation and Brownian motion simulation test. So when I go into my Matlab environment, as I said, this is the actual file, the Brownian motion simulation file with the actual algorithm as part of the code. The whole point of this is to, when you're trying to learn scripts or algorithms that look kind of complex in a research paper or wherever you get it from, the best way I find from a software engineering point of view is to actually run it, and always try to look for software source code with the research paper or whatever the book is, because you want to be able to put the link together between them and look at scientific notation and the actual code on how that is generated. That's how I learn, and that's the best way I learn at this point. So as I said, this is the Matlab M script version here of the Matlab Brownian motion simulations. So obviously we have a algorithm being built out right now. So what I'm going to do is I'm going to run this simulation. I'm just going to run it quite simply, but you also notice in the workspace here I have the values with the variables and all the data that part of this M script. So let me just run this. Let me just quit the debugger here, and here quit debugging. Okay, so this is the Matlab debugger. I'm obviously using Matlab release 2014A, which is the current version. So I'm going to run the simulation test, and as I said, let me just walk you through that point. So it's going to run the actual lines within this file, but at some point it's going to run this M script, which I'm going to just have my breakpoint in. These are the parameters it's going to send over and as input into that function. So here is the actual function as defined here with the input variables and the output via X. But when you come in to this actual script, I set a breakpoint right here. So once it meets this condition of m equaling 1, which m does equal 1, it's going to run this command. So far what we have here is we have s equaling this, as well as x is all zeros, as you can tell. Let me just run this right now and just do a step out. Let me just step. So we know that m equals 1, so it's going to run this. So we're going to do a step, which is a simple calculation. So dx isn't even created here. So it's going to do a calculation off of this s double. I think it's a vector. So let me just do a step, and as you can see now, dx is now created. What's the values of? So there's all the dx. So because I'm debugging it, I'm able to see this algorithm in action, and that's the key point of this whole video, is that debugger can help you watch how algorithms are built and how the data flows as part of that algorithm. It's kind of important because it's the key when you look at a algorithm or an equation or formula in a research paper, you got to make sure, obviously, when you hand code it from scratch, that it's done the right way. But if you're starting from ground zero, with zero knowledge, debugging any project that you can get your hands on with, as I said, source code as well as the research paper, and hopefully you can see the connection of the actual notation of the algorithm and the actual source codes and run it through a debugger, you will learn a lot quite quickly and see how it comes about. So let me just do one more calculation here. I'm going to calculate x by running this sum function here. So now you know that x has been created, and here's the results, as you can see there. So that's pretty well it in Matlab. And let me just might as well continue running it. Yeah. So there you go. It's run a bunch of created a bunch of plots created here. But you get the idea. And that's pretty well it. So the debugger in whatever IDE you use, in my case Matlab, can be very helpful in learning algorithms from the beginning, from scratch. So just want to point that out, right?